Everybody knows 4 to the second is equal to 2 to the fourth. But no one knows. Ha ha ha. But have you guys ever wondered, what if x is negative? And also, what if x is complex? Don't worry, today we'll find out everybody right here. First of all though, let me just show you guys a picture. So let's look at x squared. Of course, it's just a parabola, and then 2 to the x, it looks like this. Right? Well, as we can see, the curves intercept here and here, and this is when x is equal to 2, and this is when x is equal to 4. And in fact, any x value after 4, the green will never touch the black, because exponential grows much faster than the parabola, right? But we do know that right here we do have another x value. So these two are the only positive real solutions, and we have another negative real solutions, but we don't know what that is yet. Yeah, and in fact we have a lot of complex solutions. We'll find out everybody, and to do so we have to use a secret weapon, namely the Lambert W function. And let me write it down for you guys to see what we mean by that. So this is the Lambert W function, and this is how it works. What you want to have is that you want to have a fish first, right? So this is a fish. And then what you want to have next is that you want to have E, and then you want to have the same fish right here, right? So they are meant to be the same exact fish. Excuse my picture right here. Anyway, this fish and that fish, they have to be exactly the same. And the E, of course, it needs no introduction. The idea is that if you have this expression in your equation, what you can do is you can just take the Lambert W function, and this right here will give you the fish back. This is very, very nice, right? So this is the Lambert W function that we will be using. And let me also tell you guys that on Wolfram Alpha, sometimes you can just put a capital W for the Lambert W function, but sometimes you have to use the command. You have to just write out the product log. It's not the natural log, this is the product log, which is actually much better, right? So now, keep this in mind. We are going to look at that, right? So let me just write down the equation one more time. X squared equals 2 to the x. What we'll do first is just take the natural log on both sides, right? And when we have the natural log on both sides, this is really nice because we can take the powers to the front. Very, very nice. But do not minus 1 though, because we are not doing any derivatives, okay? All right, right here we have 2 natural log. But be really careful with this. Don't just put down x, because sometimes x can be negative. What you should be really doing is you have to include the absolute value inside of the ln right here. Again, natural log of x squared, when you put the 2 in the front, is technically 2 natural log of absolute value of x. And later on, we will have to consider if x is positive or if x is negative, right? So you have 2 cases to work on later on. And then on the right-hand side, we have the x in the front, so that's very nice. And this is natural log of 2. This is the natural log, this is the product log, right? Okay, so that's what we have at the moment. Now, we are going to collect all the x on one side and then the 2 just on the other side. Divide the x on both sides. Let me write it down as x to the negative 1 power right here. And this is the natural log, absolute value of x. And this is equal to, divide the 2 right here, we have 1/2 natural log of 2. Okay, remember, this is what we want to have. We want to have a fish, e to the same fish. So we need to introduce the e. Well, e and ln are related. Don't look at this natural log of x. Look at this right here. This right here is x to the negative 1 power. We want to somehow call out the e, and this is how we can do it. Remember, x is the same as e to the natural log of x power, right? But here's a small trouble though. We have natural log of absolute value of x. If I write this as e to the natural log of x, we don't have the absolute value there. So this is what we are going to do. Case 1 right here, and this is the case 1. What we are going to do is we will say x is positive so that we can legitimately lose the absolute value right here. And just look at x to the negative 1 times natural log of just x now. I don't know why I picked out the eraser, I still use my finger. And this is equal to 1/2 ln of 2, right? We can legitimately take out the absolute value because I said x is greater than 0 in this case. All right, now we do what we said earlier. Look at the x. Technically, it's x to a negative 1 power, but I'll write it down this way for you guys. Well, I will just write it as e to the ln of x power, like this. But technically, I should have a negative 1 right here, right? But we have the ln of x to a negative 1. I can put a negative 1 in the front, so it's negative like that. Very nice. And then we still have this ln of x. Let's put that in the front, like that, right? And this is equal to that, and let's be fancy a little bit. Put this back here. Well, 2 to the 1/2 power is the same as square root of 2. So this is ln of square root of 2, like that. Now you see, this is e, that's what we want, and this is our fish. This is negative ln of x. But remember, the front has to be the same exact fish. So I need a negative right here, so what can we do? Well, pretty easy. We can just multiply both sides by a negative. So let's go ahead and do this and do that. Very, very nice, isn't it? Now you see, this and that are exactly the same, namely the fish. So what we can do is just apply the Lambert W function on both sides. So I'll just put this down right here, and likewise, I'll put this down right here. Again, if you look at the left-hand side now, when this and that are the same, in this format, we'll just get the same fish back. Namely, we'll just end up with negative ln of x. And for the right-hand side, I'll just leave it as how it is. This is the Lambert W function of negative ln of square root of 2. And of course, if you want to be fancier than this, you can put negative right here, but I'll leave that to you guys, right? So this is what we have. And now we can just solve for x. What we can do is, of course, divide both sides by x and do e to the power on both sides. So x is equal to, well, I divide the negative right here. So we have negative Lambert W function of negative ln of square root of 2, like this. And then we have to do e to this power, so it's e to this power right here. So this right here is the first case when x is greater than 0, right? And again, on Wolfram Alpha, you will just enter the product log. But if you just enter the product log, the truth is you will only get one answer. But what you have to pay attention to is that Lambert W function is actually what we call the multi-value function, meaning that it will produce a lot of value, depends on the branch cut. When you just put down W right here, what you're saying is W0 like this, with a little subscript. So this is the principal the principal value of the Lambert W function. You can also have the negative 1, and you can also have negative 2 whatsoever. You can have any subscript that you want, any integer subscript, okay? When this is 0, you get 2. When this is negative 1, you get 4. Right? You can see on the screen right here. But how do we get the negative value though? Well, don't forget, we still have another case for that. So here is case 2, right? So case 2 right here. This is the case when x is less than 0. And we are going to look here, and again, focus on this absolute value. We know that if x is less than 0, to take out the absolute value, all we have to do is multiply the x by negative. That's all. Because that's how the piecewise of the definition of the absolute value of x. So this equation is going to look like x to the negative 1 times ln of negative x, like this. Again, if x is less than 0, negative x will make this positive, so that's good. And then this is still equal to 1/2 ln of 2. Very good. But this time, before we do this kind of thing, we have to be really careful because we have ln of negative x right here. Well, what we want to do is, we can actually multiply both sides by negative like this. So I've matched the negative x. But I want to write the whole thing as e to the ln of negative x. We have the negative 1 power though. But luckily we know that negative 1 to a negative 1 power is also negative 1. So I can legitimately write it as negative x, put a parenthesis like that to a negative 1 power. So that's very nice, right? So if you look at this part that I have right here, we can write it as e to the ln of negative x right here. And then to the -1, but the -1 can be come right here. So it's the same idea. And of course, this time, let me just put a 1/2 right here. So get the square root, I will leave that as a negative, okay? So this is going to be negative ln square root of 2, like that. Very nice. Now, I forgot to write this down. So this right here, don't forget to put it down, of course. So here we have ln of negative x. Yeah, this is that. Now, this is the fish. This is not a fish yet, but it's almost a fish by multiply both sides by negative. So multiply this by negative. Very good. Negative times negative is going to be positive, so that's very nice. All right, then of course we can just take the Lambert W function on both sides now. So negative times negative is positive, so we know that. So put W like this. All right? So this time though, this is the fish that we'll get. So we get negative ln of negative x. And the right hand side is just the Lambert W function of ln of square root of 2. Very nice, right? Oh, I should put this as a square root in red. Anyway, solve this real quick. Let's do this in your head. Do the negative first, and then take the e, and then divide both sides by negative. So all in all, what we'll get is x by itself, and that's equal to, if we have the negative right here, that's negative w of ln square root of 2 for the exponent. And then we do e to this power. And then in the end, we still have to divide both sides by negative. So this right here will be the answer. So notice they are very similar. This right here is positive e something, and then this is negative e and then something, and this right here is negative ln of something. This is the positive ln of the same thing, right? Well, this right here is the one that's going to give you the negative solution. So have a look right here on the screen. You get the negative answer as negative 0.7666646, and so on, so on, so on, so on. Most likely it's irrational, okay? So anyway, that's pretty much it. And you might be wondering, where are the imaginary solutions? Well, I wonder that too, because they're imaginary. We cannot see it. But don't worry, if you change the index here and the index here, you can produce as many imaginary solutions as you would like. Anyway, that's it. Hopefully you guys all like this video, and leave a comment down below if you have any questions. And man, I love this question so much. How about you guys? Yeah, anyway, as always, that's it.